Welcome back to Curiosity Repo, your home for exploring the greatest mysteries of science and history. Today, we're journeying to the heart of Siberia to investigate a cataclysmic event that has baffled scientists for over a century. On the morning of June 30th, 1908, a remote and sparsely populated region of Siberia experienced an explosion of unimaginable power. A colossal fireball, brighter than the sun, streaked across the sky, followed by a blast so powerful it was felt hundreds of kilometers away. The shockwave circled the Earth twice, and for several nights afterward, the skies over Europe and Asia glowed with an eerie light, so bright that people could read newspapers outdoors at midnight. Yet, when the first scientific expedition finally reached the isolated site years later, they found something deeply unsettling. They discovered a scene of utter devastation. Over 2,000 square kilometers of forest, an area larger than modern-day London, had been completely flattened. An estimated 80 million trees were scorched and knocked over, radiating outwards from a central point. But at the very center of this destruction, where a massive crater should have been, there was nothing. No impact site, no fragments, no hole in the ground. This is the mystery of the Tunguska event, the largest impact event in recorded history, which seemingly left no impact crater behind. What could have caused such immense destruction without leaving the expected evidence? Let's dive into the theories, from the scientific to the speculative, to unravel this perplexing cosmic puzzle. The most widely accepted explanation among scientists today is the meteoroid airburst theory. This hypothesis suggests that a large space object, either a stony asteroid or a comet, entered Earth's atmosphere at an incredible speed. As it plunged through the air, immense pressure and friction caused it to heat up, supercompress, and ultimately disintegrate in a massive aerial explosion between 5 and 10 kilometers above the ground. The object never actually struck the Earth's surface. Instead, all of its kinetic energy was released in the atmosphere in one catastrophic burst. This would explain the immense shockwave and the thermal radiation that scorched the forest below, flattening the trees in a radial pattern without creating a physical crater. Think of it like a colossal atmospheric bomb. The energy released was estimated to be 1,000 times more powerful than the atomic bomb dropped on Hiroshima. This sheer force was enough to cause the widespread devastation observed, all originating from a point in the sky, not on the ground. Supporting this theory are microscopic spherules of melted rock and metallic particles, including nickel and iridium, which have been found in the soil and tree resin in the Tunguska region. These elements are rare in Earth's crust but are common in extraterrestrial objects like asteroids, providing a chemical fingerprint of a visitor from space. However, the airburst theory isn't without its challenges. The primary question is the nature of the object itself. Was it a stony asteroid or an icy comet? A fragile, icy comet would disintegrate more easily in the atmosphere, which fits the airburst model well. A comet would also explain the glowing skies seen for days after the event, as ice particles and dust spread throughout the upper atmosphere could have reflected sunlight. But, if it were a comet, we would expect to find different chemical traces. The debate over the object's composition continues to fuel scientific discussion. While the airburst theory is the leading contender, the sheer strangeness of the Tunguska event has given rise to more exotic and mind-bending explanations. One of the most fascinating is the idea that a tiny, primordial black hole passed through the Earth. This theory, proposed in the 1970s, suggests that a microscopic black hole, perhaps no larger than a dust particle but with immense mass, collided with our planet. It would have shot through the atmosphere, releasing energy via particle interactions that created the explosive shockwave. If this were the case, the black hole wouldn't have stopped. It would have continued straight through the planet, exiting on the other side, somewhere in the North Atlantic Ocean. The lack of a crater is perfectly explained because the object was too small to create one, and the exit event would have been far out at sea, likely unnoticed. This is a captivating idea, but it comes with significant problems. We have no evidence that such primordial black holes exist, and the physics of their interaction with our atmosphere is highly speculative. Furthermore, scientists looked for evidence of a seismic disturbance or atmospheric event on the opposite side of the Earth from Tunguska and found nothing conclusive. The black hole theory remains a thrilling piece of scientific imagination, a testament to how far we will go to explain the unknown. but without any supporting evidence, it is considered extremely unlikely by the mainstream scientific community. Another fringe but equally intriguing theory involves one of the most mysterious substances in the universe, antimatter. The idea is that a small chunk of antimatter, perhaps an anti-asteroid, collided with our atmosphere. When matter and antimatter meet, they annihilate each other in a burst of pure energy, in accordance with Einstein's famous equation, E=mc². This annihilation would be incredibly efficient at converting mass into energy, producing a colossal explosion. This scenario would neatly explain the immense power of the blast and the complete absence of any physical fragments or a crater, as the entire object and an equivalent amount of atmospheric air would have been converted into energy. The object would simply vanish. However, just like the black hole theory, the antimatter hypothesis suffers from a major lack of evidence. We have never observed a naturally occurring chunk of antimatter in our solar system or anywhere else. It is exceptionally rare in our matter-dominated universe. Furthermore, an antimatter annihilation would produce a very specific signature of gamma rays and other high-energy particles. While we weren't able to measure this in 1908, modern analysis of the Tunguska site has found no residual radiation that would point to such an event. It's a clean and elegant theory, but one that exists purely in the realm of speculation. So, where does this leave us? The Tunguska event remains a profound lesson in cosmic vulnerability. The most plausible explanation, a meteoroid airburst, tells us that a celestial object doesn't need to physically hit the ground to cause catastrophic damage on a city-ending or even region-ending scale. The energy released at Tunguska was equivalent to a major multi-megaton nuclear weapon. If an event of this magnitude were to occur over a populated area today, like New York, Paris, or Tokyo, the consequences would be unthinkable. This is why agencies like NASA and the ESA have planetary defense programs, dedicated to scanning the skies for near-Earth objects. By identifying potentially hazardous asteroids and comets, we hope to have a warning system in place and, eventually, the technology to deflect a potential threat before it reaches us. The mystery of Tunguska is not just a historical curiosity, it is a stark reminder that we live in a cosmic shooting gallery. The silent, empty forests of Siberia hold the memory of a day when the sky fell, a memory that urges us to look up and remain vigilant. Thank you for joining us on this investigation into the Tunguska event. What theory do you find most convincing? Let us know in the comments below. And if you enjoy untangling the universe's greatest enigmas, be sure to subscribe to Curiosity Repo for more deep dives into the world of science and mystery. Until next time, stay curious.